Hello, everyone, and thank you for joining us today, and welcome to today's webinar. My name is Scott Levine, and I am the Membership Manager here at the IEEE Computer Society. Today, we have a presentation from our Standards Activities Board webinar series, which will focus on IEEE P2302 and is titled Standards for Cloud Federation by Drs. Robert Bohn and Michel. However, before we get started, I would like to address some housekeeping items. This webinar is being recorded, and you will be emailed the slides and the recording tomorrow. You can ask any questions in the Q&A box you see on your screen. We'll try to get through as many questions as possible. If possible, please reference the slide your question refers to or address the speaker who is going over the content at that time. If not, we'll do our best to address the question to the speaker or just have it a free-for-all for both of them to jump in. Before we get started, let me just introduce today's speakers. Dr. Robert Bohn of the Advanced Network Technologies Division at NIST ITL and serves as the Program Manager for the NIST Cloud Computing Program. In this role, he manages and coordinates the goals and strategy of the program, and also works with industrial, academia, and other government stakeholders to address requirements needed for the U.S. government's successful and timely adoption of the cloud computing as described in the NIST Cloud Computing Technology Roadmap. He is also the chair of IEEE P2302, which is the standard you'll be seeing today. Dr. Michel has worked in the distributed computing field for over 20 years, starting with designing data serialization algorithms for MPI, time synchronizing multimedia network streams collected using commercial off-the-shelf hardware, developing a job scheduler, and architecting data-driven research evaluation programs. He also conceived and led the team building agnostic benchmarking model to allow researchers to bring their algorithms to specialized data sets. And he is the co-chair of this standard as well. And with that, Robert, I hand the floor over to you to kick things off.
Okay, thank you, Scott. Thank you, everyone, for attending. I appreciate your time and attendance. Today, I'd like to speak about standards for cloud federation. Scott already introduced the two of us, so I'll just jump into the next slide. Today's talk, I want to to federation and our project that we're involved in, what the promise of federation is and what it holds in the future, a brief description of federation and the issues involved with it. There was a collaboration with NIST and IEEE in the development of this standard. And so I will give a brief description of that, talk about the NIST Cloud Reference Architecture, Federated Cloud Reference Architecture. If you want to, you can Google that number right there, NIST SP 500-332, and you'll get a copy of the document. Then we'll go on to talk about the IEEE work and some current status and applications and APIs. So with that, I'd like to just give the introduction now. So NIST defined a community cloud as supporting organizations that have a common set of interests. As you may know, NIST has a definition of cloud computing, which is NIST SP 800-145. So that actually lays out the fundamental tenets and essential characteristics of cloud computing. Community cloud was one of them that's described in there. But the issue is when a community cloud cannot be implemented in a single cloud, then there needs to be defined implemented mechanisms to support governance and processes to enable the federation and interoperability between different providers to form a general or a mission-specific federated community cloud. So that's the core requirement of requirement 5. If you look again at this bottom document, SP 500-293, you'll see a list of 10 requirements in that. And also another one was the promotion of international standards for cloud computing. So the promise of federation is a great one. And we all can come up with ideas of how we need to connect real-world collaboration needs, data and resource sharing with practical methods and tools. So when we think about federation, there's a few fundamental aspects. So one, it also addresses how to securely manage these collaborations when the resources are shared. And don't forget that they are inherently a distributed system. So finally, there's also a spectrum of collaboration needs and approaches. Some folks might just have a bare bones federation, small scale, manually managed, but that can extend all the way up to industrial sized federations, large scale, highly distributed, a lot of automation, accounting, auditing, legal considerations. So there's a wide range here. That's the main thing to point out, that they can be very small and they can be very large. So we're trying to address all of this at once. So when I look at a federation problem, I see the real essence here is how can user A on the left use a service from service provider B on the right? So how can he find him? How can service provider B manage his own discoverability? And how can he finally validate user A's credentials and make access decisions? Once you solve this, you're well on the way to cloud federation. So I'm just looking at the questions right now. Yeah, the slides will be provided tomorrow, like Scott tried to say at the beginning. So now the NIST IEEE collaboration. So as I mentioned earlier, we had already recognized the importance of a federated community cloud environment. And the collaboration between NIST and IEEE will build consensus on creating an intercloud, which is the open, transparent infrastructure amongst cloud providers. You can see at the bottom, we just popped in the purpose and the scope of the IEEE. You'll see that again, but in essence, the scope is to define topology functions and governance for cloud-to-cloud interoperability and federation. So the NIST work will develop a reference architecture and a vocabulary, and based on the scope and purpose from the IEEE, ultimately, the NIST work will become a special publication, and that's already been published. That work is then worked in collaboratively with the IEEE to take that as expert input and then to develop a standard based off of that. So the key point here is when NIST produces a document and then submits it for as expert input, we do not have any expectation that it is going to be treated as a golden cow and that it will not be changed. There is an expectation that standards bodies will slightly adapt or tune or change for their own benefit. So here is a three-plane model of cloud federation. So let me just make this a little bit. Okay, so we see at the bottom, we have two site administrators that really want to form Federation Foo, which is at the top. So the three planes are labeled Trust Federation plane at the bottom, the Federation Management plane in the middle, and the Federation Usage plane at the top. So the bottom plane, the Trust Federation plane, that's where all of it begins to happen. When does trust begin? How is trust implemented? The point here is there is no specific methodology for implementing trust in the NIST description, but there needs to be a trust. And so whatever mechanism that the site administrator and A and B use, that's what they implement. Once they're able to do that, they're able to create and populate instances of the Federation at their local sites. Then using secure communication between the two of them, then they can make the upper Federation usage plane where users A and B can use services from each other's site. So in the NIST work, we developed a set of essential characteristics for a cloud federation. And each federation is a virtual security and collaboration context, which is not necessarily owned by any one user or organization. And since only specific users and sites and organizations collaborate for common goals, these participants have membership in the federation and identity credentials that are linked to each member. Users, sites, and organizations can participate in a federation by sharing some of their resources and metadata and making them discoverable and accessible to other federation members. And finally, the participating members must agree upon the common goals and governance of their federation based on the well-known roles, attributes, and policies that the federation puts in place. Okay, I'm going to the next slide. So here is a picture of the NIST Cloud Federation reference architecture from NIST 500-332. It was published approximately a little bit more than a year ago. So if you're familiar with the NIST Cloud reference architecture, we use that as our model to start from. So in that model, you will also see the actors: cloud service provider, the cloud carrier, the cloud auditor, the cloud broker, and finally the cloud service consumer. So that is the basic of the initial reference architecture. Now, to turn this into a federation architecture, we have to expand upon that. The first thing we have to do is to recognize that since it's in a specific administrative domain, a federation, that has to be the first layer of it. Then, moreover, it also exists within a regulatory environment. So if I create a federation that may expand over different regulatory environments as well. One can envision an autonomous vehicle driving from state to state. Within a state, you're in one regulatory environment. When your car goes into another state, you go into a new set of regulatory environments, and your car has to know what the rules of the road are in that state or commonwealth. Let me move over to the right-hand side where the federation happens. So this is the new part of the federation reference architecture. And let's go on the outside then and work ourselves in. We have a federation operator who's in charge of ensuring that the federations take place. He'll be the one signing papers. He'll be the one making sure the funds are there to make sure the federation can operate. There's a federation manager who manages each federation instance. And the federation instance, you could have multiple federation instances, and a federation manager will take care of all of them. We can see here a federation instance does membership management, policy management, resource management, monitoring and reporting, accounting and billing, and the portability and interoperability is under their jurisdiction. So I'd like to also point out The word security is all sprinkled out throughout this reference architecture because we understand the importance of security throughout, as well as having an auditor who can come in and be either an internal auditor or an external auditor. An internal auditor would manage stuff for the company itself or the internal federation to make sure that things are working smoothly, and an external auditor might be you who want to audit the system itself. Next, we also have a federation broker who really holds a catalog of federations and runs a discovery service. So federations that are out there can then be found and used by other people searching for them. A federation will also make sure that because there's a discovery service running, they will make sure what they're allowed to just put out the metadata and a description of their federation that they want, and it might be minimal, and it might contain contact information where you can get additional information on that specific federation if you're interested in joining. Take a quick look at the Q&A here. Okay. Okay, so I am currently on slide 11, relevant existing tools and standards. So in our reference architecture document, we note that there are a lot of existing tools and standards that are available if we were able to construct one of these. So you can see on the left, we talk about securing the communication using SSL or TLS. There's identity authorization and policy category. So you could see these are a lot of techniques for identity management and authorization and policy. On the right-hand side, we bring up topics about catalog and discovery. Here are a list of those. And then finally, trust and governance. Blockchain is one possible solution, and as well as consensus algorithms. So moreover, we go into a section on additional areas of possible and needed federation-specific standards. When we talk about the federation manager, well, he has to interact with different users, sites, admins, and even other federation managers. So there would be APIs that could be used for just for the federation manager API, or federation manager to the site API, or federation manager to federation manager API. It's also possible to define a standard format for describing or defining a specific type of federation instance. So that could all be composed, and then that could be part of an introductory scheme of the discovery service that the federation broker might be able to hold to describe your federation or how you want your federation described. I see there's a question in the chat. I'm just going to break off to this. How does this model support cross-domain orchestration? How can multiple providers manage coordinators? Okay. Okay, I see Marshall is answering this. Okay. So I'm going to the next slide. So that was the completion of the NIST work. At this point, then, the NIST team communicated with the IEEE and handed this document over to them to turn into a standard. So the IEEE has their own specific objectives for this standard. The purpose is to create an economy amongst cloud providers that's transparent to users and applications, and provides for a dynamic infrastructure that can support evolving business models. So it's important to understand the word economy. An economy is something that could be bought, sold, traded, some type of commodity that we're interested in doing that with. Well, in this example, those things are cloud services, resources like compute, network. So we want to be able to create an economy where cloud providers can buy and sell and trade those types of items. The scope, as I mentioned before, is to define topologies, functions, and governance for cloud-to-cloud interoperability and federation. Overall, we would like to support a transparent infrastructure like the internet, like the phone work. Make sure that it is cloud implementation independent based on standards, much like your router or the phone network switches. It should be a simple protocol, easy to join, and support regional governance. We should also have support for generalized resource federation. So when I talk about federation, I don't mean just talking about service federation or software as a service federation. I'm talking about federation up and down the complete stack. So not just VMs. And we like to make this extensible for any type of resource type. And the community, if they wish, should be able to add their own types of resources, resource types as well. Finally, there should be support for multiple federation topologies and make sure that it's globally scale capable. Questions? Okay. So here are just some simple possible deployments. Now, of course, they can be much larger, but I'm not focusing on that. I'm focusing on the simplest ones that we could come up with. So you see on the left-hand side, we have a third-party centralized trust model. So we have the federation manager in the center, where all the sites connect to the federation manager. On the other side, we have a peer-to-peer model where two federation managers connect directly. So we could have it internal on the bottom half of the slide. Federation manager is internal to a site. Or we can have external federation managers where they're external to sites. Again, these are just possible deployments. One could keep building on and building on and building on, and then you would have just larger federations. But the simplest thing for us to do is to say, what is the most atomic structure here that we could come up with? And here it is. So in the standard, the first part that we want to describe is to look at the peer-to-peer model. What type of APIs would be necessary to get this working? So we identified three possible APIs: the member to the Federation Hosting Service API, the Federation Hosting Service Operator to the Federation Hosting Service Operator API, and then finally, where the interoperability between the two federations exists is between the two Federation Hosting Services API. At this point, I'd like to turn the talk over to my colleague, Dr. Michel, who is the co-chair of P2302. He will go on to describe more aspects of the API, more aspects of why federation is important. So with that, I'm going to go on mute and let Marshall take over.
Thank you, Dr. Bohn. Good morning. So I wanted to try to address first why federation matters to business, large and small, right? And I'm going to show you an example of something we've actually done at Data Machine. So Data Machine, we're a company, we do full stack, and we try to use cloud, obviously, to solve problems. So we have resources located at data center. We use external clouds to enhance and deliver open source solution to support data analytics problem. And those requires often AI, machine learning, and artificial intelligence resources to run. So we're talking GPU, we're talking specialized hardware. When we do that, we have to have means to basically often burst to cloud. And this slide is a good example of why cloud-to-cloud federation is not yet a commonplace solution. So what you don't see on that slide is, the CI/CD process that makes it possible to build everything. But what you see on that slide is that we're relying on Docker, we're relying on OpenStack, we're relying on Kubernetes in our data center. Identity is done using LDAP on the primary cloud. So if you look, we have 4 environments in use on that slide. We have the integration environment, that's our data center. We have 3 burst options. The first burst option was TAC, where we were using Slurm to do job scheduling and Singularity to do the containers. Second burst option was AWS with EC2, S3, and Kubernetes as an orchestration mechanism for containers. And finally, pure Google Cloud with pure Kubernetes. When we do that, we often have to duplicate data, right? So data is copied as needed through virtual private connection or virtual private networks to the different cloud, but we don't have full replication, right? What we also have is we need to be able to match identities for performers from the internal LDAP to what is being used on the remote cloud. That often involves trying to abstract or use a no user if at all possible. Compute is entirely different depending on the cloud, right? So we build containers. Obviously, the CI/CD process generates some steps in order for us to be able to confirm that a container can be validated and can be transformed. Now, moving from Docker to Singularity is just a flattening of the container. Moving the container using a container registry to another resource is feasible. And that is just a matter of reorchestrating the container to be run on the remote system. So we use different compute paradigms per cloud, and we have to work with container image that have to be migrated, pulled from registry, or transformed to match the remote system. So as you can see, federation would help tremendously to try to support that problem. This slide obviously is just a solution where we try to integrate solution organically inside the different clouds that are available to us. So I talked about Kubernetes and OpenStack, and I'm also co-chair for the OpenStack Scientific Special Interest Group. So we understand that there is a lot of people that are trying to do federation, right? But federation at the open source technology stack depends entirely on what you consider to be federation. So when you talk about Kubernetes, a Kubernetes federation is about being able to talk to other Kubernetes clusters. So the effort about the KubeFed enable different cluster, one set of API for hosting different cluster, and it's intended to be foundational, right? It's intended to try to address a multi-cluster use case. There is a multi-cluster special interest group in Kubernetes, which is trying to integrate multiple Kubernetes cluster together. Once again, multiple Kubernetes cluster together. So Kubernetes to Kubernetes, so there's a lot of work that has gone to support this, but it also becomes interesting because there is cloud providers solution within Kubernetes. So you're able to start a Kubernetes on different type of clouds. So for example, there is an OpenStack one. There is a Kubernetes cloud provider OpenStack, and you have other models that makes it possible to try to do this type of work. In OpenStack, the work for federation is mostly Kubernetes federated Keystone at this point. And I invite you to look at online. There is a couple of really good video by the Keystone people that detail how they are doing this. Now, where it becomes interesting for the identity is that Keystone support multiple form of sign-ins, single sign-ons, SSOs. And it also provides virtual organization mapping. So you can use Keystone as an identity provider. So you can have federation between multiple OpenStack. You can use Keystone as a service provider, meaning consuming identity properties that are issued by some other identity providers, such as LDAP, Radius, Active Directory, and others. So, same conclusion as in the previous slide, there is no OpenStack to Kubernetes real federation. So we don't have a commonplace model to do this type of work. So that's where we expect to have different extraction to the operating system and the cloud operating system also. And like Bob was saying earlier, federation goes beyond identity, right? It's about sharing of resources. It's about being able to share information, data, and compute in some case. So where the P2302 comes into play is that the P2302 is trying to define a set of API that are, as much as possible, implementation agnostic. As you can guess, it's not trivial. In the next slide, we are going to try to talk about the P2302, okay? The P2302 governs the interaction between the different components, between members, between federation services, and between federation hosting services through three types of API: the FHS to member, the FHS operator, and the FHS to FHS endpoints, just like was presented in the slide a little earlier. I'll go back to that slide a little later. These API enable resource, compute, services, storage to be attached, to be registered with a federation hosting service, and each federation hosting service is associated with a identity provider. So I'm not gonna go too much into detail about the identity provider, but let's go into the first API. First, it's a work in progress, right? We are still working on this. The working group is actively negotiating and discussing how to best integrate those type of solutions. The work that we're doing is based on the use of open APIs so that we can have implementation-ready models. We are using RESTful calls, and we're currently on preview one on GitLab. It is not publicly available, but the being on GitLab enables us to do that visualization of that model. So first, the FHS operator API. Each FHS, Federation Hosting Service, is a service that must be operated just like any other service, such as a web server. Therefore, there is an FHS operator that spins up a Federation Hosting Services and ensures that it is properly functioning. However, the FHS operator does not directly manage each individual Federation instance. So an FHS operator provides two types of operation. First, the core functionalities, which are the mechanism needed for an operator to manage the Federation hosting services it controls, i.e. the Federation instance, and it includes its owners, its users, through the use of the Federation admins that Dr. Bohn introduced earlier. And then you have the FHS operator, FHS to FHS functionalities, which enable the FHS to FHS communication. So going to the next slide, we are going to talk about the FHS to FHS API first, which is a little bit simpler. This API is used by different FHSs to exchange information about specific Federation instances. We introduced the notion of Federation Administrator or Fed Admin, just like was presented earlier. And a Fed Admin is a special privilege FHS account that has the authorization to create, manage, and terminate Federation instances. Fed admins are considered to be member of a Federation. And Fed admin can grant or revoke Federation membership along with authorization roles and attributes. So the FHS to FHS API allows connection disconnection of to specify the federation servers as a federation operator. They enable calls to join, update, leave a different federation hosting services. And they're set at the request of the Fed admin. And they are enables a call to validate a member credential for invoking the requested services. They are also done at the Fed admin level. We have two connected FHS will exchange information considering the currently existing federation instances, any new federation instances that are created, any update to the service catalog for any federation instances, and any update to the roles and attributes for a federation instance. The federation of member credential when making a service invocation is also done there. Just give me 1 second, please. Thank you. Sorry about that. Now, we have two slides about the members to FHS API. The first one is about how to get into members gets in through login. But before I go there, I should give you a little more detail about how those federation members interact with their federation. So there are 4 roles for members. The Fed admin, which we've already described, the service resource owner. The service owner is a member of the federation. It has the authorization to register services or resources, and it makes them available within a federation. Service owner have the authorization to unilaterally define and update the discovery and access policies for their resource based on the roles and authorization attribute known to the federation. This is an authorization that is granted by the Fed admin. So as you can see, the Fed admin is the top level operator. We have members. Now, members are federation members that can discover and access resource within a federation based on the roles or attributes that have been granted. Member is a general category. A Fed admin can create as many roles or attributes as necessary to differentiate what different members can do. And then we have a 4th type of role for members, which we're not going to talk too much in the remaining of the conversation, which is the monitoring access. It's a member of the that attribute enables the configuration and interaction of everything that is required basically for monitoring. And monitoring can go into different functions, right? It can support monitoring of resource. It can support auditing. It can support billing. So that's why we're not going to go too much into that conversation here. And the members API allows multiple things. So we have 2 slides on that. So I'll quickly show you the next slides and I'll explain each level. Login, logout, federation, FHS to FHS, attributes, membership, authorization, services, and invocation of services. So the login, logout is accessible to the Fed admin, the service owner, and the member. It creates a login session for a specified federation instance. It may cause additional interaction with your identity provider, obviously, for actual creation of member credentials. The call to manage a federation are at that level as well, also used by the federation admin member. The federation admin, the FHS level calls enables the joining of a federation, right? At the admin level, you can grant or deny are basically valid options for that functionality. Fed admin are able to query the list of federation known to the to that FHS. So that's the get federation of a federation. And then you're also able to leave a federation. I mean, you know, as a member, you have the right to join and to leave. You're able to query, you're able to join, you're able to leave. Okay, sorry. Next slide. Attributes. Attributes are basically functionalities that the FedAdmin controls for the management of the federation. So those can be the different levels accessible. We have the membership. The membership allows FedAdmin to control the membership of the federation. Members have a unique ID for a given federation. FedAdmins are also able to list the federation member, see the attributes that a given member is being granted, as well as other information on that member. You're also able to revoke the rights of the member through that federation. The authorization level is enable a FedAdmin to grant or revoke authorization for a given federation to a specific member ID for a given attribute. And you can see that at the different depth of the RESTful API. Services are meant for a FedAdmin or service owner to register a service with a federation. Get a list of service owned, get an update, delete a service, and services are accessible to the user through the invocation, depending on the access levels that are granted. The discovery level is where we are able to query a federation service catalog based on the key pair values to obtain a list of available services. The keys depend obviously on the metadata associated with the service. This function is available to all members with different level of results, obviously, right? Depending on what level access a member is granted. Finally, the invocation is a mean for members to invoke a service in a federation. We are using a lot of HTTP verbs, right? You'll see the patch add-in options here to allow service owner to have access to additional control over the service. Parameters to the service are in turn service dependent. So that's basically a catch-all API for the services themselves. I'm going to go back a little earlier to slide 15. Dr. Bohn showed you the different endpoints, and I'm just going to try to guide you through how a federation gets instantiated in that model. So the federation operator will send a federation hosting service. It will then grant FHS membership to users designated to be FedAdmins. At this point, we have a federation ready to serve FedAdmin members alone, right? Therefore, the FedAdmin's role becomes to create a federation instance, to grant and revoke membership to other users, to create roles and attributes, and then to grant, revoke role and attributes to those members. At this point, the federation is ready to serve user, but does not have services yet. So the next level is we need to add services. So service owners, which are a special type of members, can register resources. When this is done, the federation is ready to serve member and add services. Now we're talking about federation within itself being able to do things, but we're not talking about federation yet being able to talk to another federation hosting services. So that's where the FHS to FHS comes into play. So the federation operator makes a connection request to another FHS. The other FHS operator accepts the connection request from another FHS. The connected federation hosting services exchange bilateral information about their existing instances, any federation instances that are created, any update to the service catalog, and updates the roles and attributes for those instances. The validation of member, the credential, when making a service invocation is also handled at that point. Now, FedAdmin makes a join request to an existing federation. At this point, we have a local and remote federation, and they are able to provide services to their authorized member. So now when a member logs in, when it authenticates with a federation hosting services, is able to query the federation hosting service for available services. Depending on the authorization level, you get local and remote catalog entries, and they might or might not match. You might you might or might not be able to do a lot of things depending on who you are, right? At which point you can invoke the resources that you're able to call. Now we're going to go into a slide that talks at this point about an organization that is actually working, part of the working group, and is actually looking at using that model and the API. And so ORCA is the Open Resource Cloud Alliance, is investigating how to best make use of the work performed by the IEEE P2302 working group to support its efforts. Now, ORCA is trying to make it possible for researchers at different organizations or research lab from accessing resources. Now, by resources, we go beyond the simple identity, right? We talk about the full model: storage, data, compute, so that you're able to access specialized scientific data, data in other country, computational resource and specialized application, and you're also able to simply do collaboration. In order to do that, you have different type of challenges. You have data and research contents. You have problem with availability. You have problem with transportability. You need to respect local data stewardship, and you need to impose local security and data privacy rules. You need to address access and authorization. That's identity, that's security for those services. You also need to address connectivity, network bandwidth, throughput. All of that needs to be seamless connectivity and seamless transport if at all possible. You also need to be able to address infrastructure and platform services. So we're talking about compute, storage, and application. Here it's a open cloud agnostic model, right? But you also need to worry about responsible resource sharing. So in that model, ORCA proposed to be an interoperable framework. And then once again, and I know there were a couple of questions about data consideration, GDPR, things like that. Those are all considerations that you need to do when you create your Fed admin. You know, what are the rules that you're willing to exchange for clouds and research center to coexist. Research center should publish their catalog of resources that they make available. They need to have grant of rights based on agreed to standards, ULAS, TOS, data security policies. ORCA has a model where they introduce a federation participant gateway, the ORCA catalog, and identity management interoperability with data access authorization management. That means translation of identity for access and budgetary authorization. There is a consideration about a fair trade token exchange also in that model. Or if you want more detail, we put the contact link for Dr. Yazdi at the bottom of this slide. He welcomes your contact. And with that, we're done talking about the P2302. For people that are interested in learning more about the IEEE P2302, we invite you to look at the Intercloud Working Group website. The URL is posted on this slide. If you want to work with us, please, send us an email. It's a lot easier to contact Dr. Bohn or myself directly. And thank you very much for attending. And I'll pass the conversation back to Scott and Bob.
All right, thank you. That was a great presentation. There was a lot of information you two presented today. So why don't we get to some of the questions that have been emailed in or chatted in. Robert, I think I'll push this one to you, but Marshall, feel free to jump in. If there will be generalized resources for the Federation, it seems we need an agreement on language to consistently describe those resources, and providers need to agree to use that language. How is this advancing?
So hopefully that was what we were presenting in the API, right? So it's a common mean of representing information that is as best as possible cloud agnostic. What that means is that if you say, I'm a federation, I'm a member in a federation, if you use those APIs, you should be able to represent them in your own cloud or your own technology stack in order to be able to use and share resource. So where it becomes interesting is that by providing a common framework, i.e. a common API, you're simplifying the problem as best as possible to make it possible for members to just worry about communicating through those APIs.
All right, perfect. Next question. In the Cloudburst example, how were the different billing models managed? What parameters were used to decide where to burst the workload?
Oh, that's what is definitely for me. So that's actually a complex problem. It's a business question, right? And it's going to be a business answer. It comes down to money. So when you burst to different clouds, they all have different costs. And we have different relationship with those different cloud providers. So it really is a question of how much resources we expect to use. In some case, we were able to burst to TAC a lot because, that's as long as the model could be queued, i.e. use Slurm, we're able to deploy the container in Singularity and have it run. And that was like we had a relationship which made it cost effective. In other case, when you need very specialized hardware and you had nothing available, and that program was running constant evaluations, right? So we had multiple members that were coming, had to run through the CI/CD and push to our cloud. And at some point, you have to say, okay, I can't schedule you, right? Because at some point, you just don't have the resource available. So then you have to make a decision of who is available in order to make it as friendly as possible, depending on the type of data, because you also have to consider that sometimes data is, you have restrictions on where the data can go, right? On some programs, you need to consider that some data has to be protected. So you have to make a decision, you have to have a decision for the translation and the VPC to another cloud. So it's not a clear answer, obviously, because it's a cost question. Yeah, I think the short answer is really it's a cost question. I'm happy if you want to talk more about that specific one, please email me. Where is our contact information here? There you go. Back to you, Scott.
All right, perfect. Yeah, I think Mark, you sent that in. Looks like you have a couple follow-up questions based on that. So I think it would be best to connect with Marshall offline, and you guys can have a good conversation about this. It sounds like. Next question. Let's see. Robert, do you want to, where did it go? Do you just want to tell everyone what committee this all ties back to before we keep going as we wait for some more questions to come on in?
Sure, Scott. I forgot to mention that this work is also being sponsored by the IEEE Cloud Computing Standards Committee. So.
All right, great. Thank you. Yeah. Let's see. There were some good questions that came in, I think, earlier. So sorry, I'm scrolling through these. And some of these are sort of threaded. So hold on. So someone earlier was asking about, and I think, Robert, this refers to your slide 8, and she said, or they said, it comes to my mind, architectures of automated protection systems and power networks. Do they use cloud services now? And she sort of followed that up with, I believe, with a sort of, is this concept used in electricity markets?
So we're not expert in the electricity market first. So that's a little more, but it looks like, for looking at the website, the web relay she shared, it looks like this industrial control mechanism for turning on engine. I think Dr. Bohn actually made a presentation about the Internet of Things related to the Cloud Federation. Maybe you can. Maybe, Bob, you can just mention where that can be found.
Sure. Specifically about this device that you put in the chat window, controlbyweb.com web relay. So this is a specific device. And since it says that it can be used even without a computer, but you connect it through the network, I'm not really sure about the overall concept of how many of these you can connect together. Can they share data? Can you do any type of learning at the edge with them? Or are they just kind of just dumb devices? So I do understand that it can be used in the electricity and the grid system. At NIST, we have a lot of work dedicated to the smart grid and the management of power and electricity through the grid. I can envision the use of federation in certain cases, but I'm not actually cognizant of this specific device which you mentioned. So,
all right, thank you. That seems like all the questions that we've come in so far. So I would like to thank everyone for attending today and all of your insightful questions. Our next webinar from the Standards Activities Board series is on IEEE 1838, which is the standards for test access architecture for 3-dimensional stacked integrated circuits. This will be on April 20th, and it'll be presented by Adam Cron and Eric Jan Marison. The next webinar the IEEE Computer Society will be hosting, it will be next week from our Build Your Career webinar series on Essentials of Project Management by Adam Schmitz. You'll be registered for these 2 webinars plus all of our other webinars in April, which include our Distinguished Lecturer webinar series program in the email we send you tomorrow with the slides and the recording of this presentation. Again, I would like to thank all of you for attending, and both Dr. Bohn and Michel for joining us today. Thank you again, and have a great rest of your day.
Thank you. Thank you, everybody, for attending.
Yes, thank you, everyone, for attending. We look forward to federations in the future, and thank you again. Bye.